This video we're going to look at the solutions to the GCSE for CCEA Further Mathematics exam Unit 1, which is a pure maths exam, and it is you're allowed to use a calculator. Okay, first thing, notice if you have a wee read, it says give your answers correct at 2 decimal places. So we can just get started this question. Okay, question 1, it says find dy by dx if y is equal to this. So the first thing you must do is write your y in index form. So the first thing is fine, it's 2 over 3 x to the power of 6, and then this is a half times 1 over x to the 4. So you could write that whole thing as 2 over 3 x to the 6 plus a half times x to the minus 4. You're now good to differentiate. So when you differentiate, you multiply by the power. So that 6 comes down and multiplies to 2/3, and you reduce your power by 1. You multiply by the power, so that minus 4 comes down and multiplies the half, and the power of that goes down by 1. And then if you do that out, you'll get 4x to the 5, then minus, and it's going to be 2x to the minus 5. And then if you just sort that out, I would put it back as minus 2 over x to the 5, and then I'm sure I'm going to get the only 2 marks for this question. Okay, question 2 says express y in terms of x if dy by dx is equal to this. Now, how you get from dy by dx back to your how you get from dy by dx back to y is you integrate. So that's what we want to do. So again, we're going to write this in index form. So that's minus 4x to the minus 2 and then minus 4. So if you raise the power by 1, you will get 3x cubed over 3, then minus 4x to the minus 1 over minus 1, and minus 4x, and then your constant of integration. So that's a bit of a mess. Let's tidy up. That's x cubed plus 4 over x minus 4x, and then plus c. Now it tells you this point, x equals 2, y equals 7. So we'll just put that in. X equals 2, y equals 7. So 7 is equal to 2 cubed plus 4 over 2 minus 4 times 2 plus your c. So 7 is equal to, that's going to be 8 plus 2 minus 8 plus c. That is 7 is equal to 2 plus c. Wee bit of working out, your c is equal to 5. So your answer, rewrite your equation, y is equal to x cubed plus 4 over x minus 4x and plus your 5. Question 3 says sketch a graph of y is equal to cos x for minus 180 to plus 180. So I'm just going to mark on that's minus 90 here and minus 180. That's plus 90 and plus 180. You can use your calculator to check here. To cos of 0, you will get 1. So I'm just going to go for it. It goes from 1 down to minus 1. Cos of 0 is 1. Cos of 90 is 0. Cos of 180 is minus 1. And then the other side is symmetrical. So very roughly that's what you've got. So that's y is equal to cos x. Next part of the question is a cast diagrams question. That's the only way I would attempt this one. It says solve the equation 3 cos x equals minus 2. So first of all, I'd say cos x equals minus 2 over 3. Your basic angle then, and how you do your basic angle is cos the minus 1 of 2/3. Ignore the minus 2/3. So cos minus 1 of 2/3. And the basic angle I got to 2dp's is 48.19 degrees. And then I'll do my cast diagram. The only thing I mark on is where 0 is on my axes. And then now you're looking at the thing, it was cos x was minus. So it's going to be in the negative, the place where cos is negative. So that's going to be 48.19 here and 48.19 here. And it's going to be round the positive way and then round the negative way. So my answer, x is equal to plus or minus 131.81 degrees. Okay, it says hence solve the equations. So hence, so just saying, I'm going to say from previous question. From the previous question, we got that 3 cos x equals 2 had solutions. X is equal to plus or minus, I forgot what it was, 131.81 degrees. So here, that means that R1, which was 3, instead of cos x, it was 3 cos of theta over 2 minus 10 is equal to, I was equal to minus 2, sorry, it's equal to minus 2. That means the angle bit, theta over 2 minus 10, is going to be equal to the minus 131.81 or the positive 131.81. So bring the 10 across first. So do this in 2 steps, is where a lot of people make mistakes. The minus 10 comes across and then adds, so that's going to give you minus 121.81 degrees, or it's going to give you 141.81 degrees, and then multiply across by the 2, and that's going to give you minus 243.63 degrees. How have I got that? 0.62 degrees. 0.62 degrees that should be. And over here, 282.62 degrees is going to be 62 degrees. And that is within my new range, which is from minus 360 to plus 360, so happy days. Okay, next question. It says a function f is defined by, fx is defined by this. Use a method of completing a square to rewrite this equation. So I'm just going to look at my x squared minus 8x plus 24, and I'll go down. I'm going to write that, isolate the x terms, and then to complete the bracket, to complete the square of this bracket then, I would have to add in, and you might want to skip these steps. I'd need to add in plus, then it's going to be minus 4 squared. So how you get the minus 4 is you half the coefficient of this thing. Okay, I still have my plus 24, and because I've added that thing in, to keep this line equal to this line, I need to also take away that minus 4 squared. So that's what we should have, and then it's just tidying up. Tidy this up. This whole bracket would just be reduced to x minus 4 all squared, and then over here you've got plus 24, then minus 4 squared, which is 16. So it just becomes x minus 4 all squared plus 8. It says, hence write down the coordinates of the minimum turning points. Remember, we've just said that we can write this as x minus 4 all squared plus 8. So what is minimum is equal to 8, and that happens when this bit equals 0. So when x minus 4 equals 0, i.e. when x is equal to 4. So, okay, write down, it says the coordinates of the minimum turning point. So that means your coordinate, which I forgot to do first time I did this out, coordinate was 4, 8 then. And that's really what they're looking for. Okay, question 5, quadratic inequalities question. It says, a rectangle has a width x and a length 6x plus 5 as shown, and a range of values for which the area of the rectangle is less than 6 centimeters. Okay, so the area is going to be your length times your breadth. The area, is going to be equal to x times 6x plus 5. And you want x times 6x plus 5 to be less than 6. So it's a quadratic inequality question. Multiplied, you'll get 6x squared plus 5x minus 6 is less than 0. And then we want to just solve this. So we want to put, first of all, 6x squared plus 5x minus 6 equal to 0. So my sum is equal to 5, and my product is equal to 36. No, it's not. It's equal to minus 36. So go through minus 36. Minus 1 times 36 doesn't work. Minus 2 times 18 doesn't work. Minus 3 times 12. Minus 4 times 9, and that does work. So my two numbers are minus 4 and 9. So 6x squared minus 4x plus 9x minus 6 equals 0. And then factorize completely the first two terms. So you're going to have, you're not going to have that. You're going to have 2x upon 3x minus 2. Over here, pull out a 3. And again, you're going to have 3x minus 2. So we know we're on the right track. We've got the same common bracket. Write down your common bracket and write down what multiplies it. And that gives you this first bracket equals 0, which means 2/3. Or the second bracket equals 0, which means minus 3 over 2, which makes the same as minus 1.5. Okay. We draw a sketch of this thing then. It's a quadratic inequality. We now know it crosses at minus 1.5 and 2 over 3, 2/3. And we want it to be underneath the graph. So it's underneath here. So your answer is -1.5 is less than your x is less than 2/3, and that's it. Okay, next one. Matrices A, B, and C are defined by this thing. So you've got to solve AX equals C. So you had these been numbers, so say this had just been 10, x is equal to 15, you would say x is equal to 15 divided by 10. But the problem is you can't multiply by matrices. So I'm going to look at this a slightly different way, how you could do this. What you could do is multiply 10 by its inverse, which is just multiplying by a tenth. So, and if you do that on the left-hand side, you must do that on the right-hand side. So that's really what you're doing. So we're using the same sort of idea here. So what we want to do then, I'm going to just say xn, the inverse of a times x is equal to the inverse of a times c. Now, very important as well, notice I put the inverse of a in front on the left-hand side. I have to put the inverse of a in front on the right-hand side as well, because for matrices, the order matters. So it's not just like normal numerical multiplication where 6 times 7 is the same as 7 times 6. For matrices, it matters which way around you do the thing. So if I do my next line, what that will become the identity times x is equal to the inverse of a times c, and then the identity times anything just leaves it the same. So that's really what we want to get. So we need to find the inverse of a. So first thing, find your determinant of a first of all. First part of finding the inverse of a is finding your determinant of a. So the determinant of a is 5 times -3, then minus of 4 times -2, and that works out, unfortunately that works out as -7, so not too nice. Your inverse of a then is 1 over your determinant, and then you flip your elements in the leading diagonal. So in this diagonal, so yeah, they flip around, they switch around, I should say, and then you change the sign of the other elements. That becomes a 2, and that becomes a -4. All right. You could, if you wanted to, I haven't done this, but you could multiply through by the -7 at this stage to make it in the numbers inside positive. I don't think it is a massive help. So we're going to put it back into this equation over here. Just say your xn is equal to, I'll write that now, I'll just put -1/7 times -3, to -4, 5. And this is times your c, which was -2, 5. So I'll take 2 lines to do this. First of all, I'm doing a 2 by 2 times a 2 by 1. So my result is going to be the 2 outside numbers. So it's going to be a 2 by 1. So it's going to be a 2 by 1, so it's going to be a column vector again. So that's how I know it's going to be this. Okay, this element here is, how you talk about its position is very important. It's the first row, first column. That means I multiply my first row by my first column. So I'll just do that now. So that means I do -3 times -2, which is 6, plus 2 times 5. Sorry, where have I got this? -3 times -2, which is 6, plus 2 times 5, which is 10. And 10 plus 6 is just going to be 16. Okay, and the next one, I do -4 times 2, -4 times -2, which is 8, plus 5 times 5, and that's going to be 8 plus 25, which is going to be 32. So that's what I've got, which isn't too nice at all. So my answer, I could leave this as my answer, -1/7 times 16 over 32, or you might want to have left it as 7 times -16 minus 32, or you actually multiply out and you write it as -16 over 7 and -32 over 7. So whatever one you want to leave, I think I probably would have left it as this first one. Okay. Okay, part B says, explain why it is impossible to solve the equation bx equals c. If you look at your B, your determinant of B is equal to, let's look at B again. B was 3, 2, 3, 6, 1, 2, apologies. So it's going to be this product minus this product, which is going to be 3 times 2 minus 6 times 1. So it's going to be 3 times 2 minus 6 times 1. And if you do that, that equals 0. Therefore, that means matrix B has no inverse. So that's why so equation can't be solved. Okay. Right, next question, tricky one here. It says log to the base 7 of 3 is equal to A, log to the base 7 of 2 is equal to B. Express log to the base 7 of 10.5 in terms of A and B. Okay, now the hard part of this is getting 10.5 in terms of 3, 2 and also 7, because that's the base. So 10.5, let's see, I couldn't spot anything there for a minute, but then I thought, well, if I do 3 times 7, that gives me 21. And then if you do 21 divided by 2, that gives me 10.5. So 10.5 basically is 3 times 7 all over 2. So that's really what we're looking for. We're looking for log to the base 7 of 3 times 7 all over 2. Now I like to sort out the numerator and the denominator then. So numerator, it was just 3 times 7. We'll leave it as that. Then minus the denominator, log to the base 7 of 2. And then sort that out, that's log to the base 7 of 3 plus log to the base 7 of 7, and then minus log to the base 7 of 2, and then just squeezing this on here. Log to the base 7 of 3 we're told is A. Log to the base 7 of 7 is 1. If you don't believe me, check that in your calculator. And log to the base 7 of 2 we're told it was equal to B. Okay, solve this equation. So to do this, what we're going to do is take logs. So you can say that's going to be 2 over 5x minus 2, that's all in a bracket, times log of 9 is equal to log of 4. Now what normally I would do, 9 times 10, I'd multiply the bracket and then sort it away, but just for a wee bit of change, what I did this time is I divided across by the log 9 to start off. So log to the 4 over log 9. And then it's just rearranging a formula. So you've got 2 over 5 times x. Bring the 2 across, it now is going to add. Notice I'm not putting anything into my calculator just yet. This is all my working out, and I would write it exactly as I'm doing here. Don't try and be fancy or anything, just let the calculator do the work. Fire that into your calculator. When I did that, I got 6.58 to 2 decimal places, which remember in the front of the paper is what they had asked for. Okay, next question, question 8. It says for us to calculate AB. So let's just write that down. AB then is equal to 4, 3 times 3 minus 1. So 4, 3 times 3 minus 1. Now again, this is a bit of an odd one. This is a 2 by 1 by a 1 by 2. So the two outside, so they're compatible first because the two inside numbers of the order line up, and then the outside numbers give the order. So you've got, what you get here, you have a 2 by 1 by a 1 by 2, and a very unusual one, very rarely comes up, that becomes a 2 by 2. So this thing here is first row, first column. So you multiply your first row by your first column. So that's just 4 times 3. So it's 12. This thing here is first row, second column. So you multiply your first row by your second column. So 4 times minus 1, which is minus 4. This position here is second row, first column. So you do that. You multiply your second row by your first column. So 3 times 3, which is 9. And the last one is second row, second column. So 3 times minus 1, which is minus 3. Next bit of this tells us do c squared. Now c squared is c times c. I've just got rid of that, but my c is minus 1, 2, 3, 4. To do c squared, you do it out that way. A big mistake people make is they just square all the elements. You can't do that. Now that's a 2 by 2 by a 2 by 2. So my answer is going to be a 2 by 2 as well. So first row, first column. You multiply your first row by your first column. So minus 1 times minus 1 and 2 times 3 plus 2 times 3. That's going to give you 7. Then first row, second column. So first row times your second column. Minus 1 times 2 plus 2 times 4. So that's going to be 6. Again, check out in your calculator. Second row, first column. So second row times the first column. 3 times minus 1 plus 4 times 3. That gives you 9. And second row, second column. 3 times 2 is 6. 4 times 4 is 16. That gives you 22. Now the question asks us to do c squared minus ab. So remember, we have got our c squared now at 7, 6, 9, 22. And your ab from earlier on, the previous part was 12 minus 4, 9 minus 3. And fire that in. Still a 2 by 2. It's going to be minus 5. Let me just check that. Minus 5, 10. 6 minus minus 4 is 6 plus 4. 9 minus 9 is 0. 22 minus minus 3 is 22 plus 3, which is 25. Okay, this one says simplify fully the algebraic expression. So let's just look at this here. We'll sort out this bracket first of all. Going to take a common denominator of 2x inside the bracket. That will become x squared minus 4 then. And then that's being divided by x plus 2 over 6x. Now what I'm going to do is factorize the top line. That's going to become x minus 2, x plus 2, the difference of two squares. Still all over 2x. And then flip your dividing fraction. X plus 2 is now on the bottom, the 6x is on the top. Okay, I'm just going to write that out again so we can see it. And then we can also see what I'm cancelling down here. Okay, I'll put that in a bracket, makes it easier to see it cancels. The x plus 2 goes with this x plus 2 here. That just becomes a 1, that becomes a 1. And then what else can we do? One of my x's can go, this x here can go with this one. And also 2 goes into itself once and 2 goes into that 3 times. That's all the cancelling I can do. Multiplying along the top, I'll have 3 times x minus 2. Multiplying on the bottom, I'll have 1. And that's just the same as, well, you could just leave it as that, 3x minus 2. Or you could multiply it out to give you 3x minus 6. But I think that's probably just as good as any. Okay, next question says, a curve is defined by the equation y is equal to 2x cubed minus 3x squared plus x plus 5. Find the equation of the normal. So if you see the words normal, tangent, turning points, maximum, minimum, any of these words, you want to do your differentiation. So 6x squared minus 6x plus 1. And then at x equals minus 1, your dy by dx, your gradient. Remember, this dy by dx is a gradient function. So it's just going to be 6 plus 1, which is 13. So that's the gradient of the curve, which also gives you the gradient of the tangent. The gradient of the normal then is a negative reciprocal. So the gradient of the normal is minus 1 over 13. So your normal so far is y is equal to, remember, y equals mx plus c. So that's your gradient, is minus 1 over 13. And then sub in the point minus 1, you'll have minus 1 is equal to minus 1 over 13 times minus 1. And plus your c. Yep. And then so that's going to be minus 1 is equal to 1 over 13 plus c. And then bring that 1 over 13 across. You'll have minus 1 minus another 1 over 13. That's minus 1 and 1/13 is equal to c. And your last line, your normal is y is equal to minus 1 over 13 x. And then minus 1 and 1/13. Question 11 says, Jack and Jill and Jared individually deposited money in each of their 3 banks, A, B and C. Bank A pays X% interest each year, Bank B pays Y%, and Bank C, Z. Jack deposits 1,500, 3,500, 4,500 banks A, B and C respectively, and received £305 overall interest in a year. Show that X, Y and Z satisfy the equations. 3x plus 7y plus 9z equals 61. Try not to think too much about where you're trying to get to and just get started. So he puts in 1,500 at an interest rate And so the interest rate is X%. So that's X over 100. That's how much money he's going to get from that one. Puts in 3,500 into an account with an interest rate Y, so Y over 100. And then 4,500 into an account which has an interest rate Z, so Z over 100. And then that gives him £305. Now, if you just do those, 1,500 times X over 100, that just goes to 15X. Same idea, 35Y, 45Z, and that is 305. And then if you divide by 5, you will get to what you want, 3x plus 7y plus 9z is equal to 61. Now, it's exactly the same method for the next two parts of the question, just different numbers going in, basically. So Jill deposits this amount. So again, it's 1,000 times x over 100 plus 2,000 times y over 100 plus 6,000 times z over 100, and that is equal to £330 that gives her. So that's going to be 10x plus 20y plus 60z is equal to 330. And again, divide by 10 this time, you'll get x plus 2y plus 6z is equal to 33. And the last part of this one before we solve these, again, Jared, it's 2,000 times x over 100 plus 3,000 times y over 100 plus 5,000 times z over 100, and that gives him £320 interest. So again, tally that up. That's going to be 20x plus 30y plus 50z is equal to 320. Divide through by 10 to give you 2x plus 3y plus 5z is equal to 32. And there's our three equations. Okay, the next part of the question, last part of this question is to solve these. So go ahead and solve these. I will just label these equations. 1, equation 2, and equation 3. And I think that's good practice to do. Right, I'm going to eliminate my x. And also good practice is to say what you're going to try and eliminate and from where. So I'm going to eliminate x from 1 and 2. So writing that down makes you think about it a wee bit better. So I want to get the same number of x's in both equations 1 and 2. So first of all, I'm going to do, I'll write down my equation 1. It was 3x plus 7y plus 9z, and it's equal to 61. If I multiply my equation 2 by 3, so that was my equation 1, sorry. So I'm doing 3 times equation 2, and notice I wrote that down first. Keeps me right then, so 3x plus 6y plus 36z is equal to 3 times that, sorry, it's not 36z at all, it's 18z. Yep, 18z, and that's equal to 99. And then if I subtract, so I'm just going to do equation 1 minus 3 times my equation 2, and that's going to give me my equation 4. So that's going to give me y minus 9z is equal to minus 38. That's my equation 4. I'm also going to eliminate x from equation 2 and equation 3. So first thing I'm going to do, I'm going to multiply my equation 2 by 2 to get the same number of x's in both. So that'll be 2x plus 4y plus 12z is equal to 66. And then underneath that, 2x plus 3y plus 5z is equal to 32. That was my equation 3. And again, if you subtract, so 2 times my equation 2 minus my equation 3, I'm going to get it y plus 7z is equal to 34. And that's also going to be my equation 5. So I'm going to solve my equation 4 and 5 then. So just write down what I'm doing here. I'm solving 4 and 5. So what was my equation 5? It was y plus 7z is equal to 34. And then write down my other one below it. It was y minus 9z is equal to minus 38. That was my equation 4. And again, I'm going to do my equation 5 minus my equation 4. You will have y minus y disappears. 7z minus 9z is 7z plus 9z, which is 16z, and that is going to be equal to 72. And that's quite a nice number. Divide across, you'll have 72 divided by 16, which as I say is quite nice. That's 4.5. I like to put that in a wee box just to keep me right. I've got that. I'm going to sub that into equation 4. Fire that back into equation 4. I'll have y minus 9 times 4.5 is equal to minus 38. Bring that across, and y is equal to minus 38 plus 9 times 4.5. And that gave me my y was equal to 2.5. That's a 2.5, believe it or not, 2.5. Fire that back, sub back into equation 1. Where is our equation 1? Equation 1 was 3x plus 7y plus 9z is equal to 61. So that means 3x, so I'll keep them there that we can see them, plus 7y, so that's 7 times the 2.5 plus 9 times the 4.5 is equal to 61, which means 3x is equal to the 61 minus the 7 times the 2.5 minus the 9 times the 4.5 means 3x equals 3, which means x equals 1. So your answer percentages, and I would just check them in equation 2 or 3 without actually writing it down, but I've done that and they do work in equation 2. So bank A was 1%, bank B was 2.5%, that was my x, and then my y, and then my z was a 4.5. So there we go. Okay, question 12. It says write down the coordinates of the points where the curve meets the x-axis. So this means you are putting y equal to 0. So 0 is equal to 2x minus 1 upon x minus 2 squared, which means this thing equals 0. So that means, 2x is equal to 1, x is equal to a half, or this thing equals 0, which means x minus 2 equals 0, which means x equals 2. And this, because that is squared, that thing is what's called a repeated root, okay, which means, right, I'm going to sketch this. Now, part of this question is us sketching this, but we really know an awful lot about this already. If you multiply out the 2x times the x times the x, square that out, you're going to have a positive cubic graph. So it looks like that general shape. And we also know it has crosses at 2 points, and it's a repeated root at one of them. It crosses here at a half, and that's going to be 2. So I already know that. That's what a repeated root looks like. So later on in this question, we are going to see that x equals 2 is going to be a minimum turning point as well. And there will also be a turning point here, somewhere between, a maximum turning point, somewhere between x equals a half and x equals 2, but we don't know where that is yet. So you don't need to do this, this thing here. I'll highlight it. You don't need to do that, but it's good for you to have an idea, a GCSE further maths going into it, of what the curves are. So positive cubic graph, that's what it looks like. And it's got a repeated root, and there's my repeated root there. So a repeated root, it just touches the axes and no more, so it doesn't cross the axes. So we're in a good position. We know what we should be looking for. Okay, what I haven't done, however, is answer the question. It says write down the coordinates. The coordinates are a half, 0, and 2, 0. Write down the coordinates of the points where the curve meets the y-axis. So here we want to put x equal to 0. So put x equal to 0. Put it into this original equation we have up top here. Just about to see that. You're going to have y is equal to 2 times 0 is 0. You just have your minus 1. Then 0 minus 2, and that is squared. So that's going to be minus 1 times 4. So that equals minus 4. So your coordinate is 0 minus 4. Okay, next part of the question, expand fully this thing. So back, I'll do this larger again. What do we have? We have 2x minus 1 times, and I'll write that as x minus 2 upon x minus 2. So it says I'm expanding triple brackets. I'm going to leave this bit. I'll expand these other two. That's going to be x squared minus 2x plus 4 squeezed in. Tidy up. Just makes it easier just to tidy up. That's going to be x squared minus 4x plus 4. Multiply out. You're going to have 2x cubed minus 8x squared plus 8x minus x squared plus 4x minus 4. So that's going to be 2x cubed minus 9x squared plus 12x minus 4. And that's it. Okay, done. Okay, right, find the coordinates of the turning points in the curve. Right, we now know the curve was y is equal to, we've just worked that out, let me write that down again, 2x cubed minus 9x squared plus 12x minus 4. to find the turning points, you find your dy by dx, first of all, which is going to be 6x squared minus 18x plus 12. And then you want to put that equal to 0. Make life a wee bit easier, divide through by 6. First of all, you'll have 0 is equal to x squared minus 3x plus 2. And that factorizes really nicely to be x minus 1, x minus 2, which means x is equal to 1 and x is equal to 2. Right, that's how we look at this. X equals 2. Remember, way back here, we said there's a turning point. You can see the arrow pointing to it here. There's going to be a turning point at 2, and right enough, we've got that, so it's all making sense so far. So you've got x equals 2. Find the coordinates of the turning points. We've got to find the actual coordinates. So just say when x equals 1, y is equal to 2 times 1 cubed minus 9 times 1 squared plus 12 times 1 minus 4. So the y value is 1. So one of your coordinates is 1, 1. And the other one, just say when x equals 2, y is going to be equal to 2 times the 2 cubed minus 9 times 2 squared plus 12 times the 2 minus 4. So y is equal to 0. So as we had hoped, it was 0. 2, 0, sorry, is one of your turning points. Okay, almost there. Using calculus, identify each turning point as either a maximum or minimum. So you've got to do your differentiate your dy by dx. So just write that down so we can see it. Dy by dx was 6x squared minus 18x plus 12. That's what we just worked out in the last part of the question. Your test function then is d2y by dx squared. It will be 12x minus 18. And then we want to put in the x values. So just say when x equals 1, d2y by dx squared is equal to 12 times 1 minus 18. It's minus 6, which is less than 0, which tells you that the point 1 and its corresponding value is 1 was a maximum turning point. Okay, I haven't got much room here. We'll have loads. Also, we'll say when x equals 2, d2y by dx squared is 12 times 2 minus 18. 12 times 2 is 24, minus 18, that's still going to be positive. It's going to be greater than 0. Therefore, the point 2, 0 is a minimum turning point. So it's one of those weird opposite things, mathematics. If d2y by dx squared is greater than 0, then it's a minimum. If d2y by dx squared is less than 0, then it's a maximum. Okay, and your answer then, plot a couple of the points that you knew. Sorry, what have we got to say? It says, hence, using your answer from part 1 to 4, sketch the curve. So we know it crossed at a half. It had a minimum turning point at 2, 2, 0. So it's going that sort of shape there. Maximum turning point at 1, 1. And we also know it crosses here at minus 4. So that is us. Okay, I think 2 more questions to go just. Right, it says John took out an investment 20 years ago. Over the next 20 years, he recorded the value of his investment at various times. The table below shows the values of investment V in pounds after T years. It is believed the relationship forms this. Verify that this relationship is formed by drawing a suitable graph. This is a log graph question. I like to do this before I do anything else. I'm going to look at this and I'm going to take logs. So V is equal to AT to the power of n. Log V is equal to log of AT to the power of n. I would write then that means log V is equal to, split it up, log A plus log of T to the power of n, which means log V is equal to log T to the power of n. You could write as n log T and then plus your log A. Now this is going to be a straight line. This is equivalent to like your y equals mx plus c. So log V is what you're plotting in your vertical. N is equivalent to your gradient. The variable log t is equivalent to your x, so it goes in your horizontal. And if you can get it, your log intercept is log A. Quite often it's not on your graph. I think that's what happens in this one. So that's what you're looking for. You're going to do a straight line graph. Okay, so what we've got to do is find log t and log v, and you've got to do that. It says, verify this relationship And show clearly the values used correct at 3 decimal places. Okay, right, I'm just going to copy these down. I did these out earlier, so I'm just going to write these down. You get these from your calculator. And log V. Okay, right, now we've got to plot these, which is very time consuming. Hate these questions, I really do. But your log V goes on the vertical, label your axes, log V goes on your vertical, log T goes on your horizontal, and then you plot these. So you're plotting these, just to help yourself out a wee bit, I would say one small square horizontally, I would always put this down just to help you out, is worth 0.02. One small square vertically is worth 0.005. Okay, so that's what we've got. And then if you start plotting these things very roughly, so go back to your thing and plot them. Very roughly, this is where my things are. I'm doing this as quick as I can, really. I think I've missed one. I think I have. I've missed one in here somewhere. Right, you know what we're doing anyway. We're doing this as roughly as we can. Oh, here. Something's not right. There's another one over here somewhere. Right, I don't know where it is. Right, roughly that's what we've got. Then link goes up. Make sure you've got them all. There's one missing around here somewhere. Just go through and look at those, and that's how you would do that. Okay, right. What you're going to do, you're going to cheat. Now, from the next bit, it says, hence find the values of a and n, giving a correct to the nearest integer and n correct to 2 decimal places. Now, we're going to use, if you were doing this in a graph, what you would do is use nice values. Whoops, you wouldn't do that. You would use nice values, and you can, or you can just pick points that are far away. Now, to save you actually reading off and doing your rise over your run or whatever way you were taught this, what you can do is, if you know this value and you know this value and your line goes through it, you can just use what you've got for your log V values and your log T values, so it saves you a lot of time. So these 2 points I'm looking at are this point here and this point here. So that's really what we're doing to find our gradient. So that's what the gradient is. Remember, in this equation, n represented your gradient, and that's how we're going to find it. So n, first of all, so sorry, just say what I'm doing here is I'm using the first and the last. Okay, I wouldn't write this down, but that's what I'm using. But so from your graph, you make it look like you're using your graph by drawing this triangle in, and then you just use what you knew. So it's a log V difference over your log T difference, and then that is equal to 2.927 minus 2.828 over 1.301, and then minus 0.477. So when I did that out to 2 decimal places, I got 0.12 to 2 decimal places. Okay, we want to then sub that into our V, where our V is equal to AT to the power of n. So it now becomes V is equal to AT to the power of 0.12. So, and then you want to put in one of your points. So the first point I want to put in was the point I had in yellow up here. Oh no, sorry, this version of it. I've got my T value was 3, and my V value, corresponding V value, was 673.14. So we'll put that in. So we're going to say sub in was it 3673.14. So that means 673.14 is equal to a times 3 to the power of 0.12. And that means 673.14 divided by 3 to the power of 0.12 is equal to a. And this worked out to be 589.99 something or other. So a is equal to 590 to the nearest whole. So your a is 590 and your n is 0.12. Last part of the question says use the formula b is equal to at, which you now have as being this. b equals at to the power of n, which was now 0.12. Calculate how many years the value of the investment has increased to 830. So put that in as your v. And then it's a wee bit of rearranging. So get rid of the 590 first of all, bring it across. Okay, right. Now what I used to do here is take logs, which you absolutely can do. You could say log of that side is equal to 0.12 times log of t, and then go ahead, divide across, and then find a value for log t, and then inverse logs to do it. But a colleague of mine showed me a much nicer way of doing this, which is just using a wee simple button on your calculator. So if I told you that x cubed, for example, is equal to 27, you could just use your root button, and you will put into that button on your calculator the third root of 27. So here, what you can just do is say that t is equal to the, and it sounds weird, the 0.12 root of 830 over 590. We've got these amazing calculators nowadays that can do all these things. Let's use them. So that's going to be 20.959. Tells you in this question, correct to one decimal place. So this number to 1 dp is 20, oh, it's not at all. It's 21.0 to 1 dp. So use that wee trick using that button on your calculator, the one, I mean, any root button. So you can do like the 4th root, the 5th root, the 10th root, whatever, of something. That's the nicest way of doing it. Okay, last question. Question 14 says, on a remote island, the population P of lizards is modelled by the function P is equal to t cubed minus 12t squared plus 45t plus 10, where t is the time in months since the counting of lizards began. A sketch of the population of lizards against time in months is shown below. Apologies for the mess of this one here. Okay, so write down the initial population of lizards when counting began. Okay, initially means when t is equal to 0. So this is a wee bit more like a mechanics question, to be honest. But there we go. When t is equal to 0, put t equal to 0 into this up here. That's going to be 0. That's going to be 0. That's going to be 0. You're left with 10. So when t is equal to 0, p is equal to 10. Next part of the question says, using calculus, find the time in months after which the population started to fall. So let's just write down our formula again. it was P was equal to t cubed minus 12t squared plus 45 plus 45t plus 10. And we want to find when the population began to fall. So we want to find the turning points effectively here. So differentiate this. That's what you're going to have. And we're also going to put that equal to 0. And you're going to have 3t squared minus 24t plus 45. Again, that's divisible by 3, so make life a wee bit easier. Everything divides by 3. The 0 divides by 3. The 3 divides by 3. The 24 and the 45. And also that factorizes really nicely now to be t minus 3, t minus 5, which means t is equal to 3 or t is equal to 5. Using calculus, find a time in months after which the population started to fall. So here, look back and see what's going on. There's a turning point here and here. So the turning point is going to be here at this top and this bottom. So this one must be t is equal to 3 and this one must be t is equal to 5. But I think just to guarantee me getting the marks, I'm going to do my d2y by dx squared to show that this one here, because this is where the begins to fall, of course, here. So I want to show that's a maximum turning point. Okay? So just to be sure, I'll get the marks d2p by dt squared. And I do not know in the mark scheme if I need to do this. I may not. but that's what I get. And just say when t is equal to 3, d2p by t2p by dt squared is equal to 6 times 3 minus 24, which is definitely going to be less than 0. Therefore, it's maximum at t is equal to 3. Okay, and also you could confirm as well. Well, here we'll do that in the next bit, I think. Sorry, that is 3 months then is our answer. So that's when it begins to fall. Last part of the question, last part of the paper, very last question says, what is the minimum number of lizards after the population started to fall before it began to rise again? Okay, so what they're looking for, well, they're looking for, so imagine it goes up, hits a maximum, then it starts to fall, and then that's a minimum number. They're looking for this y value at this point. So we knew, we just want to test first of all, that so say when t is equal to 5, d2p by dt squared is equal to 6 times 5 minus 24, which is greater than 0, therefore minimum. And then just say when, therefore maximum, it's greater than, that's wrong, I made a mistake there. Therefore that is minimum. That's greater than 0, therefore minimum, that was right, minimum turning point. Okay, and then what was the minimum number of lizards after the population began to fall? So we want to find when t is equal to 5, what the population is. So remember it was t cubed minus 12 t squared, and then plus 45t, so that's 45 times 5, and then plus your 10. Fire that into your calculator. For the very last thing for you to do, apart from checking over your paper, you get 60 lizards. So 60 lizards was the answer you're looking for. And that is us done.